Students, welcome to Lucky Learning. Here in this video, I am going to discuss the computer instructions. As we have seen, the instruction format consisting of 16 bits, that is I bit and operation code bits and address bits. These are three parts to the instruction. In that, 15th bit will be used for mode, and 12, 13 and 14 bits are used for operation code, and 0 to 11 bits are used for addressing the memory. On the basis of opcode and addressing mode, the basic computer has three 16-bit instruction code formats. Those are called memory reference instructions, register reference instructions, and input output instructions. First, we'll see memory reference instructions. Memory reference instructions has an opcode 000 to 110. In decimal, it is called 0 to 6. And the mode bit will be either I equal to 0 or 1, 0 for direct and 1 for indirect addressing mode. When it comes to the register reference instructions, the opcode will be 111. 111 means in decimal we call it as a 7, and if it is a 7 and it requires the mode bit I should be 0 in the case of register reference instruction. It means the most significant 4 bits of register reference instructions has 0 111. In hexadecimal it is called 7. In the case of input output instructions, the opcode is 7, but the mode bit is 1. Means I equaled 1 in the case of input output instructions. It means the most significant 4 bits of input output instructions are 4 ones. In hexadecimal representation, we call it as F. First, we'll see memory reference instruction. In memory reference instruction, first 12 bits, 0 to 11, specifying the address, and bits of opcode, those are called 12th bit, 13th bit, and 14th bits, are used to specify what type of instructions. Because we have a 3 bits opcode, we can represent 2 power 3. It is 8 memory reference instructions are possible to be represented with 8 opcodes, and this value of the opcodes are 0 000 to 110, means 0 to 6 only we are using as an opcode. It means not 8, it is going to be representing 7 memory reference instructions, and the opcode is 000 to 110. And when I equal to 0, the hexadecimal representation of instruction consisting of most significant 4 zeros are 0, 0, 1, 1, 0. It is most significant 4 bits are 4 zeros. Hexadecimal representation is 0 triple X, or else 6 triple X. Means this triple X will be representing either zeros and ones. When I equal to 1, the most significant 4 bits of the instruction consisting of 1 triple 0, which is hexadecimal 8, or 1 110. It is hexadecimal 14, that is representing with E. And we know that I equal 0, it is in the case of direct addressing mode. I equal 1, it is in the case of indirect addressing mode. Register reference instructions, in that first 12 bits 0 to 11 specifying the register operation. The next 3 bits of opcode is always 111, we can call decimal 7, and the last mode bit, that is called I bit of the instruction, is 0 for the register reference instructions. Therefore, leftmost 4 bits of the instruction is always 0 111. 0 111, which is equals to hexadecimal 7. When it comes to the input output instructions, first 12 bits 0 to 11 specifies the IO operation. Next 3 bits are triple seven, that is opcode bits are triple one. Triple one is hexadecimal 7. The last mode bit, that is I bit, will be equals to 1. Therefore, the leftmost 4 bits are 4 ones, which is equals to hexadecimal F. These are 3 types of computer instructions. Now, when it goes to what are the instructions, we'll see the instructions in detail. In the computer, the memory reference instructions are totally 7. Why? Because there are opcode is representing 0 to 6. There are 7 memory reference instructions. Those are AND, add, load accumulator, store accumulator, branch unconditionally, branch and save return address, increment and skip if 0. And these are the opcode bits when the case of direct address and indirect address. When it comes to the register reference instructions, the address bits 0 to 11, 12 address bits will specify 12 register reference instructions. Those are called clear accumulator, clear E flip-flop, complement accumulator, complement E flip-flop, circular right accumulator and E, circular left accumulator and E, increment accumulator, skip next instruction if accumulator is positive, skip next instruction if accumulator is negative, skip next instruction if accumulator is 0, skip next instruction if E flip-flop is 0, or halt the computer. It means we have 7 memory reference instructions and 12 register reference instructions. And when it comes to the IO instructions, the 12-bit address will be used to represent the IO instructions. In that, the least significant 6 bits will be using to represent 6 input output instructions. Those are INP, that is input character to accumulator, output character from accumulator, skip on input flag, skip on output flag, interrupt on and interrupt off. So means totally how many instructions we have? Memory reference instructions are 7, register reference instructions are 12, and input output instructions are 6. So totally 25 instructions we are going to represent for our basic computer. These are 25 computer instructions are showing in a single slide. These are computer instructions and their type and their coding technique. Hope you have understood these computer instructions. If you like the video, do like, share and subscribe. Thank you.